Next, we're going to look at the 3x3 determinants. To set this up in the most general case, a 3x3 matrix could look like this. I'm going to use the letters A through I to represent the 9 positions. Your textbook actually uses a slightly different representation. I actually like this a little bit better if I was going to be mathematically accurate. But this one is just kind of nice because you can see the difference in the letters better. This notation with these subscripts, basically the position of the 1s and the 2s represents the row and the column that it's in. So for instance, this one here is A sub 1, 3. The 1 represents the row, being the first row, and the 3 represents being the third column. Okay, so this is A32, that's the third row, second column. So it's really like a position, a notation for the position, whereas here I'm just using the letters more simply. Just less writing. So for the 3x3 determinants, again, I mentioned this in the last video, this is not the technique I'm going to show you does not generalize to larger determinants, but I think it's more useful and quicker for what we're going to be using it for. So we're just going to go with that. So the formula that we're going to use, or the technique we're going to use for a 3x3 determinant, is to write out the first, well, write out the determinant, or write out the matrix, I'm sorry, as is, and then repeat the first and second columns after that matrix. So you go another A, D, and G going down, and a B, E, and H. Okay, so that's a repeat of the first 2 columns. Now, just like before, we're going to multiply the diagonals, but here we're going to multiply 3 things each time. So in this first diagonal, you multiply down, and you get A, E, I. Second diagonal down is going to be BFG. And the third diagonal is going to be CDH. Okay, so it's the same idea as the 2x2 to start off. Then we're going to do the diagonals going up, just like the 2x2 case. So here we have diagonal going up as CEG. We'll just put them in alphabetical order. And then we have A times F times H. And then going up here, we're going to have BDI. Now remember, in the 2x2 case, you took the bottom term and subtracted the top, so bottom minus top. Same thing here. Okay, so your final determinant is actually all the terms in the bottom minus all the terms on the top. So it'd be AEI plus BFG plus CDH minus CEG minus AFH minus BDI. Right, so you're basically keeping the terms on the bottom with the same sign. The terms on the top, you change the sign. Alright? So let's practice that with an actual concrete example. Let's look at the determinant. Make one up. 1, 2, negative 2, 5, 3, negative 1, and negative 2, 1, 4. Okay, so let's calculate that determinant. Now remember, to set this up, you need to write out the same matrix and then copy the first 2 columns down. So this determinant will equal, let's see, 1, to negative 2. I'm just going to rewrite this. 5, 3, negative 1, negative 2, 1, 4, and then I copy 1, 5, negative 2 going down, and 2, 3, 1 going down. Then I need my 3 diagonals going down to the right, and I'm multiplying on the diagonals. 1 times 3 times 4 is 12. Here I have a double negative, that's positive, and then 2 times 1 times 2 is 4. And then here I have a negative 10. And then going up to the right, double negative is positive, that's 6 times 2 is 12. Going up to the right here, a single negative is negative, 1 times 1 times 1 is 1. And then up this way, that's 20 and 2 is 40. Okay. So now when I write my final answer, I'm going to, I could just take the bottom and subtract the top, but sometimes I like to just change all the signs on top and then add everything. So I'm going to do it that way. Let's change the signs on top, alternate the signs, and then you just add them up. So you get 12 plus 4 minus 10, right? Those are the terms in the bottom. You have a minus 12 plus 1 minus 40. And just calculate, right? So 16 minus 10 is 6. I'll just write out the rest there. 6 minus 12 is negative 6. And 1 is negative 5. Negative 5 minus 40 is negative 45. So that determinant would be negative 45. Now again, there are other ways to calculate this, but I think this is the fastest and easiest to remember. Okay.